just so we keep our wording the same as we had before, cross out repetitions there, and these are our Mississippi questions. Permutations with identical objects. So we've done these before, so this is a quick review. For egg, how would I figure out how many permutations are there for the word egg? It'll be 3 factorial because that's how many letters you have, but you have to divide it by 2 factorial because you have the repetition or the identical objects with the g's, so that just becomes 6 divided by 2, which is 3. So it wouldn't be hard to write them all down. We've got egg, we've got geg, and we've got g-g-g. And those are the 3 possible ones. I'm not going to write all the ones out for Assissippi. Assissippi, which is a ski hill. How many letters do we have? 9. So we would have 9 factorial, but what do we have to divide by? 3 S's, so 3 factorial for the S's. 2 I's, 2 factorial for the I's, and 2 P's. And there's your little explanation. Your S's, your I's, and your P's.
When we're doing spaces, when you use an explanation, we're doing the formula and doing an explanation as well?
Yeah. Yeah, just quickly say how many people, how many spaces. Little explanation of what your numbers mean, right? It's not bad to put here 9 letters in total. It doesn't have to be a lot, but if you can briefly explain what all your numbers are, then if you make a mistake, like you counted 9, but there was actually 10 letters, then they'll know, oh, that was a silly mistake, and it's only a half-mark deduction. So what we have in this unit is we're going to have, and we've started sort of getting a list of strategies, and then you're going to have a variety of different questions. And then you're going to read the question, and you have to say, how am I going to read this one and say, hey, that's an identical objects question. So what you're going to be looking for an identical objects, are there things that are exactly the same? And this one, there are 3 of model A, 4 of model B, and 2 of model C. If it's an identical objects question, then you probably can represent it with letters. And then think of it as Mississippi, and we have 3, 7, 9 letters. Divide by 3 factorial for your A's, 4 factorial for your B's, and 2 factorial for your C's. You would type that into your calculator, probably use the fraction button to make sure that you have all of the stuff on the bottom. If you don't have the fraction button, make sure you put all of those things in the bottom in brackets. For this one, the 9 factorial is too big. So about the biggest was like that 10 factorial over 4 factorial, 6 factorial we did before. Be about the biggest you'd have to do without your calculator. But the majority of the questions in this unit are on the calculator part. So we've done one of these walking closer to home. We'll do this one just quickly. 3 blocks north, 6 blocks east. So draw your grid. He lives right here, right? And here's school. He wants to walk home. He's going to need to go north 3 times and east 6 times. And so this question, which we've done before, 9 factorial over 3 factorial, 6 factorial, because some of those are identical things. Going north doesn't matter where it is. Okay? Now let's imagine that something happens at school and Sally lives right here, and all of a sudden John has to make sure that he walks by Sally's house on the way home from school every time. How many ways can this be done now? Maybe it shouldn't be Sally because it looks like school, but we'll know that that's Sally's house. So how many ways could John go home now? 2 ways of doing this. 1, we have 2 now decisions to make. He's got to walk to Sally's place first, and then he has to walk home from Sally's place. So how many ways could he walk from school to Sally's place? Well, that would be 2 norths and 2 easts, which would be 4 factorial over 2 factorial, 2 factorial. And after he walks to Sally's house, now he has to go home from Sally's house. And to go home from Sally's house is just north once and east 4 times. So that would be 5 factorial over 4 factorial. First thing he needs to decide is how he's going to Sally's house. The second thing he needs to decide is how he's going home. This is the number of choices to go to Sally's house. This is the number of choices to go home. And so this becomes an identical objects question with a spaces question combined. And that's what we're going to notice with our strategies, is that our strategies will also start to get combined together. So if we calculate what this is 6 times 5. There are only 30 ways that he can get home now if he needs to go by Sally's house. You can also do this Sally question by saying the counting strategy we saw the other day. How many ways can we get to this point? Only 1. How many ways to this one? Only 1. How many ways to this one? Still only 1. The only pathway is straight across. This one will be only 1 as well. These areas are now blocked out, right? He's never going to go to those intersections anymore, because then he would be backtracking. So now there's 2 possibilities to get to this one, 3 possibilities to here, and 3 possibilities to there. Remember, we just add the 2 diagonals to get to the 3rd one. So to get to Sally's house, we find out that there's only 6 ways to get to Sally's house. Now, continuing from there, how many ways are there to get to this spot? If there's 6 ways to get to Sally's house, how many ways are there to get to that spot? No, still 6. Because the only way to get to this spot is to go here. There's technically a 0 there if you want to think about it. And if you add those up, that'd be 6. Similarly, this will be 6, this will be 6, and this will be 6, and this will be 6. Then 6 plus 6 is 12, 18, 24, 30. The same answer that we got from the other technique. So you can look at these questions in either of those ways.